stability. I'm not saying it reduces. I said it affects the ship's stability. And it's very important then to evaluate the stability of the vessel in the damaged condition to ensure that the vessel is saved stability wise. Else, you could be facing the ultimate outcome. So, therefore, you have to be very, very careful about the ships in case they suffer any bilging. Mind you, I have not said that stability is always compromised. No, I said stability is affected, impacted. So there could be a adverse effect on stability. There may be slight increase in stability, but unless you know what is the effect, how would you take corrective measures? So to be able to take corrective measures, you will need to evaluate the stability of the vessel in the bilged condition, and then only can you take further, decide on further course of action, and therefore the topic assumes importance. Okay. Now, when the vessel is intact, when the vessel is intact, what do you have? You have the weight of the ship. So let's say, just for the sake of easy explanation, let's have a box-shaped vessel. It can be any shaped vessel, doesn't matter. Let's say we have a vessel, box-shaped vessel of length capital L, breadth capital B, floating in intact condition at waterline WL at a draft D. Okay. Now, let us say, guys, there is a compartment midships. It can be anywhere of length small l, breadth small b, and the compartment is empty. Now the vessel is floating in the intact condition. We all know why the vessel is floating, why it is not sinking more, or why is it not coming out, why there is no further immersion, or why there is no further immersion. It's not happening because in this condition, the displacement of the ship is totally balanced by the buoyant force of buoyancy, which is acting upwards. What is buoyancy? Buoyancy is the weight of water displaced. In this condition, and what is the weight of the water displaced? So, what is buoyancy, guys? Buoyancy, you all know, is weight of water displaced. And what is this weight of water displaced equal to? It's equal to volume of water displaced into the density of the water. Now, if this buoyancy is equal to the displacement of the ship, there is an equilibrium between the two opposing forces, one acting downwards, other acting upwards. And the vessel strikes an equilibrium and is now floating at draft D. Yes or no, beta? Am I right? Correct, class?
Yes,
Yes,
sir.
sir.
So here, the balance is between W and B. Which volume in the intact condition is contributing or providing the buoyancy? Obviously, the underwater volume of the vessel is displacing water equal to the underwater volume in this case. And so let me divide this underwater volume into three parts. Let's say part 1, part 2, or V1, V2, and V3. In the intact condition, the buoyancy will be equal to total underwater volume V1 plus V2 plus V3 into the density of the water, whether it is seawater or dock water. And this buoyancy, as long as it's equal to displacement, the vessel will be in equilibrium, there will be no immersion, and there will be no immersion. Neither the draft will decrease nor the draft will increase. Right? Do you all appreciate this equilibrium in the intact condition, or anybody has any questions or any doubts in your mind about this condition, guys? Don't think we are not touching bilging. Everything that where I start from gets connected eventually to what you're doing. So if anybody has any doubts about buoyancy or anything, please let me know. Through which point is the buoyancy assumed to be acting, guys? It's assumed to be acting through the point called as center of buoyancy, which we represent by capital B. Through which point is the weight of the ship assumed to be acting through? It's assumed to be acting through center of gravity, which in diagrams we'll represent by capital G. All this you're all familiar with. Am I right, guys? Yes or no?
Yes, sir.
Now, what will happen if this compartment, which was earlier empty of length small l and breadth small b, if this compartment gets bilged, that means it gets damaged, its structure gets damaged below the waterline, not necessarily keel, it can get damaged on the sides also, as long as the damage is below the water line. What will happen? Since the compartment was empty, all of you know water will rush into this compartment. Am I right, guys? Yes or no? Correct, Beta?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now, this compartment will start getting filled up with seawater. So, what is the change that has happened vis-a-vis intact condition? The change that has happened vis-a-vis intact condition is, in the intact condition, this dam compartment was empty, and now seawater has found its way into this. Now, this ingress of seawater can be looked at in two different ways. It can be looked at in two different ways. Okay. Now, one school of naval architects, so the water which goes inside the compartment is looked into in two different ways. One is that one set of naval architects or one school of thought is that this water which has gone into the ship's compartment can be considered as the weight loaded on the ship. It is like you have taken ballast in a compartment. So they are saying one way of looking at this water is okay, it has come inside my ship structure. Let me treat it as weight added. Now, if you treat it as weight added, all of you know what will happen. The draft will increase because the displacement has now increased from W to something new. Correct, guys? Correct? If
Yes, sir.
this weight of the water
Yes.
here is the weight added, then the displacement of the ship will no more remain W. The displacement will increase. And when the displacement increases, the buoyancy which was at draft D will fall short of the new displacement. And since now buoyancy falls short, the displacement having become more, there is a resultant downward force. And this resultant downward force causes the vessel to sink. Why is the vessel sinking? Because you said new displacement is now short of, is greater than the buoyancy available at draft D. So why is it sinking? It is sinking because there is a resultant downward force. Now, as this vessel sinks more and more, additional volume will go under the water. And what will happen? That buoyancy will start increasing. This sinkage will happen until the time the new buoyancy becomes equal to the new displacement. Am I right, Peter? Does it make sense? Yes or no?
Yes, sir.
Yes, sir.
Correct.
Yes, sir.
When the new buoyancy, which is new underwater volume multiplied by density of the water, when the new buoyancy becomes equal to the new displacement, the vessel will reach another equilibrium at a new draft, D1. So water will rise in this compartment up to this level. So this is the water which is assumed to have been added to the vessel. So the new displacement will be the old displacement plus the weight of the water in this blue box that I have made. And at W1L1, the buoyancy will also be equal to it, and a new equilibrium has been established or a new equilibrium has been reached. Very logical, guys. Yes or no? Correct?
Yes, sir.
Now, if you follow this process, what I have just described, the naval architects who follow this process of dealing with the water that has come in This method is called as added weight method. Sometimes these questions can also be the theory questions. So this method will be called as added weight method. Why? Because you are assuming that the water which got into the ship because of bilging is the weight added on board or loaded on board, whatever you want to say. And guys, you have done so many questions of MV hinge ship, non-MV hinge ship, in which whenever the weight is loaded or discharged on the ship, it does change the stability of the vessel. Yes or no? Am I right, beta?
Yes, sir.
I'm not saying whether it increases the stability or decreases the stability. When you load a weight, what can it change? It can change the kg of the ship. It can change the GM of the ship. It can change the trim of the ship depending on where the weight has been loaded. And it can change the list of the ship depending on where the weight has been loaded. So you are all very conversant in handling the stability of a ship when a weight is loaded on the ship at any location. Am I right, guys? You know how to get the final drafts, list, GM, everything you know. Correct? Am I right, guys? Yes or no? Correct?
Yes, sir.
So added weight method is like loading of additional weight and there is nothing new. So if somebody says describe added weight method, I hope you can explain to them that under this weight, the water which finds its way into the bilged compartment is considered as the weight added on the ship. And since when the weight is added on the ship, it will change the stability of the ship, and this method is called as added weight method. Is the added weight method clear to everybody, guys?
Yes, sir.
Okay. What all changes in added weight method is what you already know, but I'll have a quick review of it so that there is in intact condition, in the bilged condition, right? Now, in the added weight method, we have just said that the weight which has gone into the ship is considered as weight added. So guys, why does that so will the draft change? Will the draft change in added weight
Yes, sir.
method or will it remain unchanged?
Change means
Change.
increase.
We are not talking about how much यार जितना पूछा उतना ही कर ले यार कहाँ जाएगा आगे भाग के क्लास से Okay. So there will be a change in draft. Can you tell me what was the reason for change in draft? Was it reduction in buoyancy or was it an increase in displacement? What was the trigger?
Increase in
Increase in
The trigger was increased displacement. Correct, beta? This is the trigger for change in draft. Will the displacement increase? Yes. Displacement is also increasing because the weight is added. Now you all know what happens to the hydrostatic particulars. 8 of them are listed against draft, or if you enter against displacement, again draft becomes the eighth one. So what happens when if the draft or the displacement change, do the hydrostatic particulars change of the ship? Yes or no, beta?
yes, sir.
All hydrostatic particulars will change. A change I have already written on top. So what all will change is what I'm writing here. Okay. Guys, when you add a weight, does it potentially shift the or does it has the capability of shifting the center of gravity of the ship? Yes or no? When
Yes,
you
sir.
add a weight on ship, does it have the potential of changing the center of gravity location? Yes or no?
yes, sir.
Yes,
Yes.
sir.
So your center of gravity in all likelihood, unless you add right at the old center of gravity, then of course there'll be no change. But if you are in all probability, the center of gravity will shift. Now, center of gravity shifting is broken into three components. One is the vertical component. So that means the kg will change or is likely to change. The LCG is likely to change. And even its location with the center line, the transverse location is also likely to change. The kg will cause a change in gm, and hydrostatic particulars have also changed. LCG would lead to change, and hydrostatic particulars together will lead to change in trim, and this can lead to change in list. Am I right, guys? Yes or no? Very simple, correct? If you talk sensibly, stepwise, it'll there is nothing new. It's all adding stepwise. Guys, in the last diagram that I have made, do you think in this compartment, this is the free surface which was earlier not existing, it is created now? Yes or no? Am I right? Correct, beta? Okay. This is the free surface created. So, guys, if FSM, if every time it may not be, if free surface is created in the bilged compartment, the FSM of the free surface will add to FSM of the ship. Very logical, guys. Yes or no? Am I right? Correct. Now, whether the FSM changes or does not change, tomorrow there may not be a free surface created. The compartment may be completely filled up with water, like a DB if it gets bilged. So the FSM may not be created. So FSM may remain unchanged. But in that case also, FSC will always change. Why? Because the displacement has changed. Even if FSM remains same, change of displacement will cause a change in FSC. Am I right, class? Yes or no?
Yes, sir.
Okay. So now you know what all changes have taken place. You can find the new parameter, whatever is required, whether draft, whether GM, whether list, whatever, the way you have been dealing with the loading of the weights, which you are very conversant with. Okay. So guys, if there is a short note to be written on an added weight method, would you be able to explain and write whatever we have discussed over the last few minutes, 5, 7 minutes?
Yes, sir.
Would you be able to address the theory part of it, Vita? Right?
Yes, yes.
Okay. So that is added weight method. Now there is another school of naval architect which say, nahi, we don't want to treat it as the weight added on the ship. What is their logic? Their logic is this. This was the vessel in the intact condition, floating at this waterline WL at a draft of D. Had this empty compartment of length small l, small b, and the compartment is empty. Now, this compartment suffers bilging. Now, we had called this volume as V1, V2, and V3. Now, guys, which was the volume, which all volumes were responsible for providing buoyancy, which we can call as volume of buoyancy? Which all volumes were responsible for providing buoyancy? Can you tell me? Was it V1
V1,
plus
V2,
V2
V3.
plus V3, right? All three of them, correct?
Yes,
Very
sir.
good. And this volume of buoyancy was equal to volume of displacement. What is volume of displacement? The displacement of the ship divided by the density of the water. So this volume of buoyancy and volume of displacement were same. Yes, fantastic. They were in equilibrium. So if you multiply volume of buoyancy by density and you multiply volume of displacement by density, one becomes displacement, other becomes buoyancy. Both are equal. The vessel is in equilibrium. Fantastic. Now, like the earlier case, let this empty compartment get bilged or suffer bilging. The water enters into this compartment. Now, guys, when you ballast a tank, or what do you do? After the ballasting is done, you shut a couple of valves, including the sea chest. Am I right, Peter? Correct? You shut the tank valve, you shut the bulkhead master, and then you shut the sea chest. I'm sure you all agree that after you complete ballasting of a tank, you shut a series of valves. Yes or no? Am I right?
Yes. Yes.
What do these valves do? These valves cut off the sea from the tank. They cut off the sea from the tank. So whatever is the ballast taken is now confined within the ship's boundary. It cannot go out to sea. Why? Because you have shut down the valves. But in this case, when the bilging takes place, water rushes in definitely. It fills up the compartment, it goes to a certain level. But can you now close the hull which is bilged? No. Okay. Now what happens? This water of its own choice goes in and comes out. Now you'll say, why does it come out? Now, guys, when the vessel pitches, the draft outside will reduce and this water will come out because it will tend to equalize with the draft outside. When the vessel goes down in a trough, the outside draft increases, more water will gush it. That is what I mean by the water freely going in and out of the ship's compartment. Do you agree, guys? Am I right? Correct, correct.
Yes, sir.
What level does this water try to maintain inside the ship? It tries to maintain the same level as the level of the sea outside. If the level outside, the draft outside reduces, this water will reduce. If the draft there increases, this water level will increase. So it is like if there is a tidal port, if the tide rises, the sea water everywhere will rise. I'm not talking of draft now, I'm talking of something else. And if tide falls, the sea level falls. Now, the thing here is that this water of its own choice is free to come in and out and freely communicating with the sea. If something is freely communicating with the sea, does it remain your stuff if there is a breach of border with an enemy country and people are freely passing information? Do they remain part of your country? No, they
No, sir.
become part of the enemy, right? Okay. So, likewise, here also, this water inside the bilge compartment is coming in and going out of its own choice based on what is the draft outside. That means this water you have no control over. The water is inside the ship's hull, agreed, but you don't have control over it. Okay? So, what will happen? When you don't have control over it, that means something belongs to you only if you can control. If you don't have control over something, it may be lying in your house. If there is a locked suitcase full of money lying and you don't know how to open the suitcase, then that money is useless to you. Am I right, Beta? Correct. So, likewise, this water which has gone into the compartment does not belong to you. Why? Because you cannot control it. It is like the seawater outside. Guys, you remember yesterday we did that question on two cylinders, right? Did this water belong to the raft? Did this water belong to the raft in between the two cylinders?
No, sir. No, sir.
So if I remove this full keel here, don't you think it becomes like the raft yesterday, like this?
Hmm.
The structure will become like this? Yes or no? Correct? Am I right?
Yes, sir.
This will become like this. So what happens? This water, you have no control. Likewise, this water, you don't have control. So what does this naval architect, School of Naval Architects say? That if I don't have control over this water which has come into the compartment, that means that water does not belong to me. In fact, this space, whatever it has occupied, has joined hands with sea. It has become part of the sea. It does not remain part of the ship. So if we consider that this has joined hands with sea and stopped helping the ship's cause and is no more contributing to ship's cause, then what happens? Earlier you had V1, V2 and V3. three of them contributing to buoyancy. But now, if the compartment is bilged, then volume V3, which was under the water earlier and contributing to buoyancy, has now stopped contributing to buoyancy. Correct, beta? Why? Because it has joined hands with the sea. So if V3 stops contributing to buoyancy, so in the bilge condition, at draft D, which are the volumes that will contribute to provide buoyancy? Only V1 and
V1, V2.
V2. But the displacement of the ship is much more. If you multiply with this by density, this will be less than the displacement. Now buoyancy has fallen short. Displacement has not changed, but buoyancy has fallen short because some of the buoyancy was lost because of bilging. So again, buoyancy is less, displacement is more. There is a resultant downward force which will cause the vessel to sink. Why? Because there is a resultant downward force. As she sinks more, the buoyancy will increase, and at some new draft, whatever it may be, when new buoyancy becomes equal to new displacement, the vessel will reach a new equilibrium. Okay, now in this case, has the draft increased? Yes. So what all has increased here? The draft has increased. But what is the trigger for the change of the draft? What was the trigger? Buoyancy becoming less than displacement. Correct, beta? That was the trigger for draft to increase, correct? So
Yes, sir.
outcome is same as the previous case. Outcome is same as under added weight method. The vessel goes to draft, new draft in both cases. But in added weight method, the trigger was assumed increase in the displacement. Here the trigger is, there is a assumed reduction of buoyancy. Since this method is based on concept of heating buoyancy having been lost, this method is called as lost buoyancy method. So why it is called lost buoyancy method is clear better? Yes or no? Right?
Yes, yes, Captain.
Okay. So now let me make a list of things which will change here and not change in this method. What will change? You just told me draft would change. Very good. It's going to change. What will happen to displacement? Is the displacement changing in this method, guys? Is the displacement
Yes,
changing?
sir.
Why? Why
No,
the
sir.
displacement?
No.
Have, have you added any weight on the ship, beta?
No, sir. Sorry.
No, no, it's okay. So the displacement does not change. Why? Because the water inside the bilge compartment does not belong to the ship. It has joined hands with the sea. So if it does not belong to me, it cannot be part of my displacement. Correct, beta? Now,
Yes.
if the draft has changed, the water plane area will change. So whatever will change with the water plane area, there will be some changes in the hydrostatic particulars. So some hydrostatic particulars will change obviously. Okay, like center of buoyancy will change. Because why center of buoyancy will change? Because you're losing the buoyancy here and you're gaining it somewhere else. Okay, so therefore center of buoyancy will shift. Water plane area shape has changed, so center of flotation will change. So LCF, LCB will change, KB will change. This means the KB will can change, LCB can change. When I say change, if there are you create ideal situation, they may not change. Center of flotation will change. Okay. Now all the particulars where water plane area and buoyancy have a role to play, the center of buoyancy, they will also change. So KM will change. KMT, KML will change. Okay. TPC, center of flotation has changed, so TPC can also change. So you have 1, 2, 3, 4, 5, 6, 7, and 8th is displacement. Displacement is not changing. Okay. Now, guys, tell me. I'm saying when I say change, they may not change if there is an ideal scenario. Okay, if you create a very specific case, and some of them may not change, but yes, they have a potential to change. Guys, tell me one thing. If something does not belong to you, like in this case, the water will rise up to this place, and there is a free surface of the water here. But is this the free surface of the water of the ship, or is it the free surface of the sea water outside? Tell me.
Sea water outside.
Sea water
Outside.
outside.
Sea
Why?
water.
Because this water does not belong to me, it belongs to sea. So this is the surface of the sea. Okay. So therefore, the free surface inside the tank does not bother you. The free surface, if caused, does not add to ship's free surface. So guys, if FSM does not change in all likelihood and displacement does not change, so FSC is unlikely to undergo a change. And the most important advantage of this one is FSM, other is when does the center of gravity of a ship change? When you either load weights or discharge weights or shift weight. Under this method, you have neither loaded any weight, added a weight, nor have you discharged any weight, nor the weights have been shifted. So there is no trigger for center of gravity to shift because displacement has not changed, distribution of weights has not changed. So your kg, your LCG, and your transverse center of gravity, they will all remain unaffected under this method. Is that clear, Peter? Clear, class?
Yes, sir.
So, under lost buoyancy method, many a things change and many a things do not change. Now, technically, which method is superior? Technically, both methods are equally good or equally bad. Okay. So don't be under any impression that added weight method or lost buoyancy method is superior to the other. Technically, both are same. They are equally good or equally bad. They may not give exactly answer in every case, but they are both good or bad same. You cannot say this method is superior to the other. Then if there is no technical superiority, then the preference of a method boils down to the convenience of the user. Am I right, guys? If there is no technical superiority, then which method would you prefer would depend in a given scenario based on what helps, what you find convenient. Am I right, guys?
Yes, sir.
Yes.
Yes, sir.
Now, in most cases, because the displacement does not change, the center of gravity does not change, and the free surface inside the bilge compartment does not bother you, therefore, lost buoyancy method becomes more convenient in most of the cases. Therefore, most cases we use lost buoyancy method. Only stray cases where you can see clearly that added weight method is making my life easier, I may switch over, but I will not switch over on day one. We'll talk about it on day last when we do bilging. So what is the preferred method? Preferred method is lost buoyancy method. Reason for preference, not the technical superiority, it's the convenience because many important parameters do not undergo a change under lost buoyancy method. Am I clear to everybody?
Yes, Captain.
Okay. So please don't tell me tomorrow that I told you lost buoyancy method is better. No. Lost buoyancy method is more convenient and that's why most of the times we'll be using this. So if you want to put down anything, put down. This can also become compare lost buoyancy method with added weight method, describe any one of them, whatever it is, that can be part of your theory question also. So please don't mess it up if it comes in theory. I give you 15 seconds to have a quick recap of these two things. and clarify if there's any doubt before I proceed further. And what we'll be following now when we describe in the further description will be lost buoyancy method, guys. Okay, let's move on. Now, guys, what did we see that the draft has increased? So in every case, the first requirement will be to get the new draft at which the vessel will float post bilging. What will be the new draft after bilging? So that will be the first requirement that will come. And that is called sinkage. Now, I don't have anything, everything I do in hand because requirements change from batch to batch. People come with different types of doubts, and therefore it, it is always explained live in the class, guys. So please feel free to let me know if you have any questions. Guys, now we'll find sinkage in lost buoyancy method. Okay. I'm keeping the compartment midships. We'll keep moving the things later on. Let's first learn things in steps. Guys, when we do the questions, you will have to use notations because otherwise, if you start using values from the word go, your life will become miserable. Whenever we do the questions, the length of the ship will always be represented by capital L. The breadth of the ship will always be represented by capital B. The draft in the intact condition the water line will be always represented by WL, and the draft in the intact condition will always be represented by small d. And let us say this ship has a midship compartment extending from side to side or not, doesn't matter, has length small l. So compartment length will always be represented by small l. Breadth of the compartment will always be represented by small b. Okay. Now, this compartment is empty. Now, when this compartment gets bilged, the vessel will sink to a new water line and reach a new draft. The new water line will be called as W1L1 in all our working. This new draft after bilging will mark as D1 in all our calculations. And this change in water line, the change in draft, is what we'll be calling as sinkage. Is that clear, Beta? So first step will be to calculate sinkage, because if I have the sinkage, I can add it to D and I'll get D1. Is that clear, Beta? Am I right?
Yes, sir.
Okay, guys. Now, in the, okay, now, in the intact condition, okay, I'll clear this diagram. So I have explained this. I'll mark them now in steps. Okay, I'll clear it off and then ask you. Otherwise, in this diagram, some of you will again start going left, right, because I'll add W1, L1 in steps. We have length, breadth, and the vessel is floating here. L, B, empty, and draft D. We have volume 1, volume 2, and volume 3. Now, guys, in the intact condition, volume of buoyancy is equal to V1 plus V2 plus V3. I'm sure everybody agrees with it, right, Peter?
Yes, sir.
Correct? Now, if this compartment gets bilged, which buoyancy is lost? Which buoyancy is lost if this empty compartment is bilged?
V3.
V3. So that means now I'm shading the lost buoyancy. Now somebody may say, sir, water will rise further up. That will be lost buoyancy. Guys, in the intact condition, the volume above the water line is your reserve buoyancy, which will help you in surviving if there is bilging. So buoyancy lost is not up to the new draft, it is only up to the intact water line, correct? So do you all agree with me that buoyancy lost will be in this case V3, but if I write it in notational form, I'll because every time we'll not call it V1, V2, V3, this is equal to small l into small b into d. Does everybody agree? Yes
Yes,
or
sir.
no?
Excuse me, sir. Could you explain
Yes,
that
sir.
again? I didn't quite catch that
No, I
about
asked you. So you tell me which buoyancy is lost.
V3.
So that what is V3? If I have to calculate V3, tell me how. It's a box-shaped thing I made. So what will be V3? As per you, what do you think is V3,
Length
Samuel?
into breadth into initial draft.
No, no. Use small l, capital L clearly. There are multiple L's and
Small b and small d.
that's what I have also written, Samuel. Correct?
Okay, okay.
Yes or no? Correct?
Yes, sir. It's just I didn't understand what you said
No, no, it's okay.
regarding the
No, no, it's
draft.
okay. No, it's okay. It's okay. So that's what now it's clear. Okay.
Yes,
Now
sir.
this loss of buoyancy under lost buoyancy method we just discussed a while back will lead to sinkage. The draft will increase and the vessel comes to equilibrium at a new draft. What is the new water line? W1 L1. Okay. This draft we said is D1 and this is what we call as sinkage. Guys, first tell me, as the vessel sinks in the bilge compartment, will the water rise between WL and W1L1 or will it remain stopped at WL only?
Price W11.
Everybody
It will
agrees?
rise.
Okay. So now
Yes, sir.
I'm not crossing it. I'm putting dots here. Guys, if you follow these simple processes, these have been developed over a lot of years to basically figure out what suits the students most. So water will rise up to W1, L1. So my dotted blue portion shows that water in the compartment rises up to W1, L1. Now, guys, which additional volume, which additional volume has gone underwater? Now I'm using the word underwater. Now I'll start separating the terms. Be careful about what I'm using. So which are the volumes which have now got immersed because of sinkage? I'm sure you'll agree volume A, volume B, and volume C. Correct, beta? These are the three volumes which were earlier above the water line and have gone underwater now. Am I right?
Yes, sir.
Does everybody agree that the volume that has
Yes, sir.
additionally gone underwater is small a plus small b plus small c? Does everybody agree? Yes or no?
Yes. Yes, sir.
Use your common sense and tell me tell me even if you whatever comes to your mind. Do all the three volumes, small a, small b, and small c, do they all contribute to buoyancy in the bilge condition? All the three, yes or no?
No.
No.
Which one does not contribute?
A and
C.
B.
C, sir. C.
C does not contribute. Yes, A and B contribute. I think that's what he was also trying to say. Probably he didn't get my question. So everybody agrees that out of three volumes, small a, small b, and small c, only small a and small b will contribute to buoyancy. C does not, because C is part of the compartment which has betrayed you and joined hands with the sea, right?
I
Correct?
lost
Right.
buoyancy.
Correct? Okay. But
Yes.
C is not lost buoyancy. C, because C was not contributing to buoyancy in the intact condition. So don't misuse the word. The moment the lost buoyancy will remain up to WL only, right, guys?
Yes, yes. Okay.
C was never contributing to buoyancy in the intact condition, and she continues not contributing to buoyancy in the bilge condition also, right? So you
Yes.
can lose something what you had. C was never part of the buoyancy packet. So how can C be lost from there, right? Correct, better?
Yeah, yeah,
Okay.
correct.
Okay. So we regain some buoyancy. What is the buoyancy regained because of sinkage? Buoyancy, as per my diagram, buoyancy regained because of sinkage is only A plus B. Am I right, guys? Yes or no?
Yes.
Correct, guys?
Yes, sir.
Correct. Correct.
Okay. Now, let us visualize, let us visualize the water plane area at W1 L1. I'm writing here. And please participate in say speaking out water plane area at W1 L1 in which condition? In the bilged condition. Guys, what will be the shape of the overall water plane area at W1L1? Imagine the ship to be cut at W1L1. Tell me,
A rectangle.
Big rectangle.
rectangle of what dimensions?
L into B.
Capital L
Okay.
into capital B.
So you will see the ship structure at the water line like this. And then you'll see this bulkhead and this bulkhead being like this here. Am I right, guys? When you cut the ship, will you see the seawater here? Yes or no? At the water line,
Yes,
when you
sir.
cut at W1L1, will you see seawater from top
Yes.
in a bird's eye view?
Yes.
Yes.
Yes. Yes.
Okay. So this total length of the water plane is L. The total breadth of the water plane is B. But this part of the water plane is not intact. It is lost to sea because this is occupied by seawater. And what is the length of this water plane? Small l. And what is its breadth? Small b. Small b can be same as capital B or less than that. Doesn't matter. Okay. That's why it's being written like this. Does everybody agree that some water plane is lost? Yes or no? Am I right, guys?
Yes.
Now I'll introduce few terms which need to be clearly understood because we'll be using them in our discussion. One is whole water plane. Whole water plane in this diagram is capital L into capital B. Then lost water plane area in this diagram is small l into small b. The remaining area which is still intact is called as intact water plane area, and which will be here in this case. One, somebody can say, sir, I'll add A1 and A2. Yes, you're right. That is the intact area. But normally, just to so that most of the questions it keeps fitting in comfortably. Yes, you can do A1, A2, but I think a convenient way would be if I say whole water plane minus lost water plane. Does anybody have any objection to instead of saying A1 plus A2, if I say whole water plane minus lost water plane, will I be left with the intact water plane? Yes or no? Am I right?
Yes, sir. Right.
Guys, everybody understands? So please don't misuse these terms. They have specific meaning. Whole water plane does not mean the whole is intact. It's the whole water plane of the ship's hull. It may be fully intact as it was in an intact ship, or it may not be intact as in this case. Then lost water plane. If it is lost, then how much is lost? And then what is the intact? From the whole, if I knock off the lost one, will I be left with intact water plane? Yes or no, class? Everybody is on board up to this point, guys? Correct, beta?
Yes, sir.
Yes. Sir. Yes.
Okay.
Yes, sir,
Now,
correct.
yeah, very good. Now the guys, the same way as I am saying that I could have done A1 plus A2, but I prefer to do it whole minus lost. Same way, I can calculate small a and small b and add them. But a more convenient, universally or applicable right thing would be like this. Guys, visualize this part of a cuboidal thing, this one, only between these two water lines. I'm making it here like this. This is W1L1, right? This is like this, like this, like this, like this, like this, like this, like this. This is your WL, this is W1L1, and this is sinkage. Do you agree with me, guys? Yes or no? Am I right? correct? I have only made between this diagram is only in this range. This is what I have made here. Correct, guys? It will be like
Yes.
this.
Yes.
Correct. Out of this, this much is lost. This volume you said was A, this volume was B. But instead of calculating A and B together, guys, tell me, is the water plane in the bilged condition? Pay attention to my statement. Is the water plane in the bilged condition same as this one from WL to W1L1? Yes or no? Is the water plane at WL like this? Yes or no? With this much lost at WL, is it this the water plane? If I cut the ship in the bilge condition here, will the water plane be same? Yes or no? Correct, class.
Yes, sir.
Yes.
If I cut the ship somewhere between WL and W1L1, will the water plane be same? Some of it will be lost. Yes or no?
Yes.
Correct. Water plane at W1L1, you have already agreed. That means the water plane from WL to W1L1 in the bilged condition is same. Does everybody accept it or anybody has any doubts? Okay. Guys, can you close your register and put it flat or notebook flat on your thing on table? The notebook will look like this, what I have kept. Yes or no, beta? Correct?
Yes.
If I ask you to calculate the volume of the notebook, what will you do? You'll measure the length of the notebook, you'll measure the breadth of the notebook, and you'll measure the height of the notebook, and you'll multiply and give me the volume. Fantastic. Now, if in your notebook, I cut out some part, it may be from one end to the other, or it may be something here like this. Now, if I cut out from one page to the other, why did you multiply capital L and capital B with the height? Because the area of each page was same, because each page was length into breadth. Therefore, you multiplied with height. Am I right, guys? Yes or no?
Yes,
Correct?
sir.
Now, if I cut out some portion from here, from your notebook, then what will happen? The area on each page will be like A1 and A2. Yes or no? Correct? Correct, beta? Capital A1 and A2. Correct, beta?
Yes, sir.
Now, if I have to calculate the intake, the wall A plus B here, one is I can calculate A plus small b. Second, can I take the intact water plane and multiply by the height of the notebook? If I cut out from your notebook something and then each page has the same area, the cutting is same in on all the pages. So every page has lost same area, correct? If every page loses the same area, then the left area in each page will be same. Yes or no? Correct, Peta?
Yes.
And if I can calculate whatever is left out in the page and multiply by the height, will I get the left out volume now? Remaining volume? Yes or no?
Yes,
Yes.
sir.
Do you agree with me? Yes or no? Tell me,
Yes.
beta.
Yes.
Yes,
Yes.
sir.
Okay. So instead of calculating A and B separately, if I tell myself that, and what is A and B? You have already told me A and B is the buoyancy regained. So if I write like this, am I making any mistake? That buoyancy regained will be equal to intact water plane area. When I say water plane, I mean water plane area multiplied by sinkage. Am I making any mistake, guys? Buoyancy regained will be intact water plane area into sinkage. Like I told you with your notebook, if you cut out the same area from your notebook on all the pages, then how can you calculate the remaining volume? Remaining volume will be the remaining area on each page multiplied by the height of the notebook. Yes or no? Am I right, guys?
Yes.
Anybody in the class who is not on board, please let me know. Because once I clear this, then coming back will unnecessarily eat more time better. If you have any doubts, let's discuss them here. Okay, guys. The vessel floats on law of flotation. Vessel will float on law of flotation. So how much buoyancy has the vessel got to regain? She will regain as much as she lost, because buoyancy cannot become more than the displacement of the ship. So how much will the buoyancy the vessel will regain? The vessel will regain buoyancy equal to what it lost. So therefore, by law of flotation, buoyancy regained has to be equal to buoyancy lost. What is buoyancy regained we have got? We have got it as intact water plane into sinkage. How much is the buoyancy lost here? You wrote it as small l, small b, small t, but I'll only say lost buoyancy, whatever it is. From this expression, what do you get sinkage equal to, guys? Sinkage is equal to lost buoyancy divided by intact water plane. Do you agree with me? Yes or no? Correct? Please review it. Let me know if there is any concern or any doubt. This is the formula which will be used to calculate the sinkage that is caused. Please take your time. You can take 30, 40, 50 seconds, 1 minute to review it. And if something is not clicking with you and you want any more clarification, I'll try and change examples if I can. So let me know what are your doubts. Everybody seems to be aligned, is it? Shall I take it that way, class? Because there are no questions coming. Clear, beta? Because after this, we'll go to the questions then. And of course, questions will start with simple ones, then variations will come. All that will be part of the learning process. So if there are no doubts, can I go to questions then, guys? Please let me give me a go ahead if everybody is okay with it. Class,
हाँ जी सर.
can I go ahead with the question?
Yes, sir.
Because then
Yes, sir.
then suddenly you'll start saying, "Sir, ye kya tha?" Then it derails the entire rhythm, of the class also. If there's any doubt, let me know. Yeah, there's absolutely no rush. Okay. So we are good to go on questions. Please remember sinkage is equal to lost buoyancy upon intact water plane. And now I'll tell you stepwise the process of doing these questions. As through a question, I will tell you. Here is the first question. Next sheet also it's the same. No, yeah, it's the same. No, yeah. So here I'll do the before bilging. I think this must be before bilging or after bilging. I don't know what is it. Okay. After bilging is this answer, and before bilging is something else. Okay. Yeah, this is a before bilging. Okay. Guys, before bilging, you already know. I just want to revise again so that people don't. Now, guys, what you'll do, I'm doing part one right now. I'm not doing the bilging part. I'm doing the intact part right now. Guys, how do you get GM based on our discussion in moment of inertia? This is the intact vessel. It's a box-shaped vessel. Guys, as I told you, length of the ship. Beta, if you're not speaking to me, please mute yourself. There's some mic which is creating some noise. Length of the ship will always represent by capital L, 100 meters. Breadth of the ship will represent by capital B. Is floating at an even keel waterline. The draft is small d, which is 6 meters in this question. Kg of the vessel is 7.5 meters. It has a midship compartment. Length small l 30 meters, small b 20 meters. Compartment is empty. The vessel is intact. We have to calculate the GM of the vessel. Guys, how do we get the GM? We have just done it in the applications of MOI. How do you get the GM of a ship?
Km minus kg minus FST.
Okay. Is there any indication? Is there any indication of FSC? Very good. So GM will be equal to KM minus KG minus FSC. Is there any indication of FSC? No. So obviously we'll
No.
have to take it zero, right? Is the KG given in the question? Yes or no?
No, no, sir.
Yes, sir.
A
KG
kg
is not
given.
given.
7.5.
7.5.
7.5.
So that means what do you need to calculate? KM.
Yeah.
In
Okay.
last to last class, we focused a lot on KM. What is KM equal to?
KB plus
KB plus
BM.
BM.
Plus BMT.
KB plus BM. What will be the KB in this case for a box shaped vessel?
Draft
Half
Three,
the
rate.
draft.
3 meters.
Meters.
What is the
Hmm.
formula for BM of a box shaped vessel? Don't waste time applying that
B
moment of
square by
inertia.
12D.
B square upon
I by
12D.
B
V.
square by
B
12D.
square by
So B square by 12D minus 7.5 minus 0. This will be the GM in the build in intact condition. Anybody who has not understood, let me know. I have just revisited it so that you remain connected to the previous topic also. Please calculate and see. Calculate and see. Anybody who has doubts on GM in the intact condition. So that is not connected to today's topic. We are talking of what we learned day before yesterday or the class. Yeah, what we did in the third class, we learned how to calculate the KN, right? Box shaped vessel, triangular barge, and then combination water plane and all that we learned, right? So please tell me, everybody's okay with 1.055? Have you got the answer? Bolo bhai, fatafat.
Yes, yes.
Okay. Now we go to the bilged part of it. Now pay attention, beta, and anytime you have any doubt, just unmute and interject. Okay. Guys, when we deal with the bilging thing, diagrams are very important. First, we'll make the side profile view. What do I mean by profile view? This one. So first make the intact condition. Pay attention, this will hold the key to the entire discussion. Capital L, the length, capital B, the breadth, intact water line, WL, draft, small d, 6 meters, then the compartment in question, small l, 30 meters, small b, 20 meters is empty. This is this bilge condition or intact condition, guys?
Intact condition.
Intact
Now,
condition.
okay, very good. Now, after this, I'm changing my marker to red. This what I have done is the intact condition. Now, then, based on the question, you will shade the lost buoyancy. Okay. I am sure in this case, you will agree that the lost buoyancy is this. So you'll shade it like this. Correct, beta?
Yes, sir.
Right? Then you know that, and we are following lost buoyancy method class. Okay. Under lost buoyancy method, if buoyancy is lost, that will cause the vessel to sink and she will come to a new equilibrium. Of course, if she sinks and does not survive, then you're not here to do all this, right? She sinks to a new water line W1 L1. Correct, beta? Does everybody agree?
Yes, sir.
Now, you will look at the situation and then ask yourself this question. Will the water rise from in the bilge compartment from WL to W1 L1? What is your answer? Yes or no?
Yes.
Yes.
Yes. Just dot it. Don't cross it because crossed one is the lost buoyancy. Otherwise, it will mislead you. Okay. We'll have the final draft of D1 here when it comes. Any questions on this side profile diagram clear, guys? Is that clear to everybody what is to be shaded, how it has to be drawn? Now, next you will draw the water plane area at which level, at what draft? W1, L1. The bilged final draft. Based on our discussion on the previous slide a while back, I'm sure, and if you don't agree with me, please let me know. I'm sure you'll agree that the water plane area will be 100 meters by 20 meters. You will see these bulkheads here, and this will be lost. एक minute, beta, just give me a minute. Okay, sorry guys. Now, this is the lost water plane whose length is 30 meters. See how it is being marked, and breadth is 20 meters. Capital B and small b may be same, they may be different. So it doesn't matter, whatever it is. Everybody is good up to this point, guys? Anybody has any questions? So first you will make the side elevation, and right below that, you will make the water plane area at W1, L1. Am I clear?
Yes, sir.
Clear? Now, next you will find is the sinkage. And you see, it's very simple, beta. Sinkage is equal to, you can see your notes. We said it was lost buoyancy upon intact water plane. Now, guys, the numerator, lost buoyancy, you will get from the upper diagram, the side profile. You have already shaded. Give me in the notational form, what is the lost buoyancy, guys?
Small l into small b into small d.
Small b.
Very good. And intact water plane will get by whole minus loss. So what is in the notational form, the whole water plane, guys? Whole water plane is how much? In the notational form.
Capital L, capital L,
Into,
capital B.
very good. What is the lost water plane, guys?
Small L
into small b.
small.
All the values are there on the diagrams. You just have to put the values and find out the sinkage and give me how much is the sinkage, beta. Please put the values, and if anybody has not understood the step, let me know. Yeah, tell me. How much is the sinkage you're getting, guys?
2.571.
Sorry,
2.571.
2.5.
2.571.
Okay. So what you'll do in the next step, beta, you'll put like this. Very good. Okay, good. Small l 30, small b 20, d is 6 meters, capital L into capital B minus 30 into 20. And you said 2.571 meters. Everybody is good with it, guys? Anybody in the class? How much will be D1 then?
8.571.
8.571.
Very good. Put it on the diagram. Guys, whatever I'm telling you steps, if you follow them religiously, don't try to cut short. Don't try to unnecessarily go left, right. You will have no problems. Now, guys, we need the GM in the bilged condition. So what do we need to calculate? We need to calculate Km. In which condition? Bilged condition. What is Km equal to? Km is equal to Kb in the bilged condition and Bm in the bilged condition. Now, guys, in this case, Kb will come D1 by 2. But I'll tell you later when will it be D1 by 2. And if you can make out, you can avoid calculations. But every time it is not going to be D1 by 2. Whether it is D1 by 2 or not, whenever you have doubt also, you can also always resort to calculations. Okay. Now let me tell you how to calculate KB. Though I know it will be D1 by 2, but we have to learn the method of calculation. Guys, KB will be calculated by principle of moments. And moment about which axis? Keel. Now, whatever I'm messing up the diagram, please don't do that. Don't mess up your diagram. In the bilge condition, which are the volumes which are contributing to buoyancy? This is one volume which is contributing to buoyancy. This is the other volume which is contributing to buoyancy. Am I right, guys? Yes or no?
Yes, sir.
Yes, sir.
Where will be the KB of this one? Here. Where will be the KB of this one? Here. Where will be the combined KB at the same height? Yes or no? Am I right? Correct,
Sir,
Peter?
sir.
Okay, but we will calculate it. Now, if I have this volume 1 and volume 2, I can take their moments, add them, but I will not do it that way. Now pay attention to what I'm saying. The way we did whole water plane minus lost water plane instead of adding the two water planes, here also we'll do it, and you will learn whatever I speak, I'll speak umpteen number of times, and you need to repeat to yourself silently. Guys, tell me one thing. If I call, can I call this volume as underwater volume in the bilge condition? Yes or no? Can I call this as underwater volume in the bilge condition? Yes or no?
Yes, sir.
Yes, sir.
How much will be the underwater volume in the bilge condition? In notational form, tell me, in this case, what do I multiply
Volume
to?
volume of
L into B
number
into
one and
D1.
L in capital L into capital
Into
B
capital L
into
into
D1.
Capital B
D1.
into D.
Okay. What will be the KB of the underwater volume? Geometric center, rather. Let's not call
D1
KB.
by 2.
D1 by 2. So if I multiply the underwater volume up to W1 L1 with its lever about keel, will I get the vertical moment of underwater volume? Yes or no? Yes or no?
सर एक
Yes,
बार
sir.
रिपीट करेंगे प्लीज लास्ट स्टेटमेंट.
I said if I multiply the underwater volume up to W1 L1 with its lever from keel, will I get the vertical moment of underwater volume
Yes,
about keel? Yes or no?
yes, sir.
Yes.
Correct. Out of this entire underwater volume, out of this entire underwater volume, this volume now where I'm making the red box is not contributing to buoyancy. Correct, beta?
Yes, sir.
Out of this underwater volume, can you tell me in the notational form which volume is not contributing to buoyancy?
Small
Small
L
L
into
into
small
small
B
B
into
into D1.
D1.
Very good. If I take the lever of this volume about keel, I'll get the vertical moment of the volume which is under the water but not contributing to buoyancy. Am I right? Can I get the
Yes, sir.
vertical moment of this red volume also? Correct, beta? So instead of adding the vertical moment of one volume to other volume, what I'm doing now, from the whole, I'm subtracting what is not helping my cause. So can I say that if I take the vertical moment of the underwater volume and from there I knock off or subtract the vertical moment of the volume which is under the water but not contributing to buoyancy, what will I be left with? Tell me, what do you think I'll be left with?
Intact buoyancy.
We'll be left with vertical moment of volume of buoyancy, right, Peter? We'll be left with vertical moment of, you don't have to write, I'm writing only for explanation. I'm saying if I take vertical moment of underwater volume up to bilged water line, and from here I subtract vertical moment of underwater volume not contributing to buoyancy. What will I be left with? Will I not be left with vertical movement of volume of buoyancy? Yes or no? Am I right, beta?
Yes, sir. Yes, sir.
Guys, anybody who's not understood what I have written, please let me know what is your concern. I'll try to help you out. Does everybody agree? And guys, if you have the
Yes.
vertical, if you have the vertical movement of the ship and you divide by displacement, what do you get? Kg. And
Yes.
if you have the vertical movement of volume of buoyancy, if you divide with volume of buoyancy, you'll get kb. Yes or no? Am I right?
Yes.
Vertical moment divided by this is the vertical moment of volume of buoyancy. If I divide by that volume, I'll get the kb. Yes or no? Correct,
Yes,
beta?
sir. Yes. Correct.
How will you do this? Will you write like this? No, you'll do like this. kb final is equal to. So this step was only for explanation. You don't have to put it in your working. If you have to calculate, we'll not even calculate for this going forward. It's a straight case. Now I'll talk to myself and put in the notational form. That's the best way to do it. So first I say vertical moment of underwater volume up to W1 L1. If I have to talk of moment, I have to identify two things: which volume and what is the lever. So underwater volume I identify from the diagram. It's capital L into capital B into D1. Then I look at the diagram, where will be its geometric center from keel. It will be D1 by 2. This is the vertical moment of underwater volume up to W1 L1. From here I subtract and tell myself vertical moment of underwater volume not contributing to buoyancy, and I look at the upper diagram to identify that volume, that in this case that is LBD1. Then I identify the lever of this volume from keel. It's D1 by 2. That is the vertical movement of volume, underwater volume, not contributing to buoyancy. Now, divided by what is the principle of moments? A1 plus A2 or V1 plus V2. In this case, it is V1 minus V2. What is V1? It is LBD1 minus LBD1. It is principle of moments, guys. Am I right? I have done nothing here. First, you'll write like this, talking to yourself silently. You will write it in the notational form. Is that clear, beta? Class?
Yes, sir.
Anybody has any questions? Were you asking something, beta, or you are confirming that it's okay? Somebody was
Sir,
saying.
can you explain please again?
Which part? You have to specify
Uh,
the part. There's nothing like
yes, sir.
explain again.
नहीं हो सर, L into B into D1 divided by D1 by 2 minus वो वाला.
हाँ तो तुम बताओ ना क्या है वो. ऐसे नहीं होता ना, सारा एक्सप्लेन करो. यू टेल मी व्हाट इज योर कंसर्न.
Sir,
ऊपर में there is something written in words. Yes or no?
yes sir, right.
So how do you find vertical moment of anything in the ship?
Intact
If you have
water
to
plane
find
area.
vertical moment of the weights, how do you find out?
Sir, वो intact water plane area.
अरे यार, if you want to find vertical moment of weights on ship, how do you find? Question तो सुन लो.
Okay.
हाँ, शिप में वाटर वर्टिकल मोमेंट वेट्स के कैसे निकालते हो? कभी यूज किए हैं?
Okay.
This is the problem, ना. ये है, but he doesn't know what he does. He knows it. I know everybody knows how to calculate kg, and he has also done it, and he knows, but he can't understand vertical moment है क्या भला. You don't use vertical moments when you're calculating kg? Yes or no?
Yes sir, use. Yes sir, use.
Have you not used vertical moments in Simpson's rules for buoyancy? kb निकालने के लिए?
use करते
Yes or no? यूज
Yes,
होते
sir.
हैं?
ये होते
Okay.
हैं सर.
जो मैंने जिस पे बॉक्स बनाया वो क्या लिखा हुआ, पढ़ो उसको.
Sir, vertical moment of underwater volume up to water level 1 to
So
what?
now, how do you get the vertical moment of anything? If it is of the volume, You'll have to identify the volume and the lever. Yes or no? And what is lever?
Yes, sir.
What is lever per moment? Your problem is not LBD1. उसको मैं 50 बार भी repeat करूंगा, you'll still be there only. Your problem is somewhere else. How do you get the moment of a volume about any axis?
Sir, moment.
How do you get the moment of volume about any axis is my question, beta.
सर लीवर यूज करके मोमेंट यूज होता है, लीवर यूज
And
करके.
what is lever?
वॉल्यूम इनटू केजी, वॉल्यूम इनटू केजी.
What is lever? लिवर तो मल्टीप्लाई करते हो, बट लिवर होता क्या है? तभी तो लिवर पता चलेगा, तभी मल्टीप्लाई करोगे ना समीर.
यस सर.
या व्हाट इज लिवर? In case of volume, it is the distance of the geometric center of that volume from the reference axis. Which is the reference axis in vertical moment? कौन सी एक्सिस के अबाउट ले रहे हो मोमेंट्स?
एक्स एक्सिस.
एक्स एक्सिस कील के अबाउट ले रहे हैं यार. That see the problem is somewhere else. तूने फेज 1 दिया नहीं दिया अभी एग्जाम?
हाँ दे दिया सर.
तो वहां पे केबी नहीं निकालते थे, केजी नहीं निकालते हो?
हाँ निकाल देते सर.
तो फिर वर्टिकल मूवमेंट नहीं लिए क्या वहां पर?
हाँ ले लेते सर.
फिर so now tell me what is the so जो बॉक्स में लिखा है तुमने पढ़ा है वर्टिकल मूवमेंट ऑफ वॉल्यूम अंडर वाटर वॉल्यूम अप टू W1L1. so what is the volume in notational form up to W1L1? tell me what is the volume.
सर
How do I get
कैपिटल
that?
एल, वॉल्यूम सर कैपिटल एल कैपिटल बी इनटू D1.
okay, and what will be the distance of its geometric center from keel? इस ग्रीन बॉक्स को, जो बड़ा ग्रीन बॉक्स बनाया, उसका ज्योमेट्रिक सेंटर कहाँ होगा? उसका कील से कितना डिस्टेंस होगा लिवर?
और सर D1 डिस्टेंस डिवाइडेड बाय 2, D1 डिवाइडेड बाय 2.
D1 by 2 बोलो ना. so what now you have understood what is LBD1 into D1 by 2?
या अंडरस्टूड सर.
ओके नाउ नेक्स्ट बताओ कैसे अंडरस्टूड. मैं यहाँ नहीं छोड़ने वाला तेरे को. हाँ नेक्स्ट क्या लिखा ऊपर बॉक्स में?
देन
वर्टिकल
वॉल्यूमेट्रिक
मूवमेंट
मोमेंट.
ऑफ अंडर वाटर वॉल्यूम नॉट कंट्रीब्यूटिंग टू बॉयंसी. सो ये जो ग्रीन बॉक्स बनाया था, इसमें से कौन सी वॉल्यूम है जो तुम्हें बॉयंसी को कंट्रीब्यूट नहीं कर रही? डायग्राम देखो.
बीच वाला सर V3.
व्हाट इज द V3? क्या है उसको
Which
कैसे निकालेंगे? व्हाट इज द फॉर्मूला फॉर दैट?
सर देन स्मॉल
अरे
एल स्मॉल
नॉट. हाँ हाँ.
इनटू D1.
उसका लिवर कितना होगा?
D1 बाय 2.
समझ में आ गया?
हाँ सर समझ में आया.
और जब नीचे में क्या करते थे? V1 इंटू KB1 प्लस V2 इंटू KB2 अपॉन V1 प्लस V2 करते थे ना सिम्पसन रूल में.
यस सर.
वहां मोमेंट्स ऐड करते थे तो वॉल्यूम्स को ऐड कर देते थे. करेक्ट.
करेक्ट है करेक्ट.
यहाँ पे मोमेंट्स को सब्ट्रैक्ट किया तो क्या किया? वॉल्यूम्स को सब्ट्रैक्ट कर दिया. एक वॉल्यूम क्या थी? LBD1 कैपिटल L कैपिटल B एक D1. दूसरी वॉल्यूम क्या थी? स्मॉल L स्मॉल B इंटू D1.
यस सर
Correct.
राइट.
That's how
Correct,
you got
correct.
the done. Everybody is clear now. Now please put the values and give me the KB. You know all these values. समीर फटाफट इनकी वैल्यूज डालो. KB की वैल्यू दो
Okay,
मुझे.
Sir, 4.286.
4.286. Okay, that's correct. No, have you made it half or you have calculated it better? That's what I want to say.
What, sir? No, sir. Calculation.
Okay, okay. No, I just wanted to know because half करोगे 8.57 उनको तो भी यही आंसर आएगा. That's why I was asking you.
Sir, 4.286.
Very good. फटाफट निकालो वैल्यू. समीर कंफर्म द वैल्यू once you get.
यस सर यस सर.
हाँ सर, वैसे तो D1/2 ही आएगा ना।
आएगा, वो बाद में बात करेंगे उसके बेटा, ठीक है।
नहीं, अभी आप जो कैलकुलेशंस आपने डाली है उसमें भी D1/2 ही आएगा।
वही आएगा, वही
अगर
आएगा।
उसको हम बाहर निकाल ले कॉमन को, तो दोनों डिनोमिनेटर डिनोमिनेटर कैंसिल हो जाएंगे।
करेक्ट, करेक्ट, इसे करेक्ट, यस यू राइट। हाँ भाई बच्चों, क्या क्या खबर, हाउ फार? सैमुअल फॉलोइंग इन प्लेस?
Yes, sir. I got, sir. I'm trying to find
Good.
BF.
Good. Oh, there's a power cut. Guys, I'll wait for a few minutes. If it does not set in, then I'll take everything down. Leave, or I'll have to make some arrangements here to connect power back. Take a second. Okay, what's the time? Guys, let me just make a power supply. It's 11:02. Can you take a 5 minutes break? 11:07 we resume, and those who have not calculated KB, please calculate. Okay. 11:07 we did. Okay. Yeah, I'll just make arrangements.
Okay, sir.